And I also gave you some assignment. Did you guys do the assignment? Anyone tried anything from the assignment? No. Okay. Okay. And so let us start with a question that we have in our NCERT, and then we will begin with today's topic. Okay. So you have also pending those assignments from the homework. Okay. I've given the homework that also you have to do. And let us try some question. One more question from NCERT. Please write. Calculate the number of. Calculate the number of kilojoule of heat necessary to raise the temperature of 60 gram of aluminium from 35 degrees Celsius to 55 degrees Celsius. So stuff, and they have written molar heat capacity of aluminium. It is given as 24 joules per mole per Kelvin. Per mole per Kelvin. So in this question, first of all, you have to understand what is this particular molar heat capacity in terms of its units. Okay, very important to understand the molar heat capacity with in terms of its units. Why is the camera not on? Abdul Hamid, Martin, Mariam, and Harsha, can please turn the cameras on. I just realized. Thank you, Abdul Hamid. Waiting for Mariam, Harsha, and Martin.
1 minute, sir. I will open.
Okay. See here. What they have said about the so they're talking about the molar heat capacity of aluminium as 24 joules per mole per Kelvin. What does that mean? First of all, it means 24 joules of energy, or rather I should say heat. 24 joules of energy or heat. Energy, don't write. Listen, it's important if you understand it. Not everything is there for writing. Okay, try to understand first and then write. 24 joule of energy is required, is needed to raise the temperature of 1 mole by 1 Kelvin. So if I have 1 mole of aluminium, and this aluminium, it has a temperature of, let us suppose, 25 Kelvin or 25 degrees Celsius, 298 Kelvin, 298 Kelvin. Right now it is having a temperature of 298 Kelvin. I'll have to give it 24 joules of energy to increase the temperature to 299 Kelvin. Is that clear? Yes or no? Please tell me, guys. Yeah, that clear is up. Okay. Now they are talking in terms of 1 mole. I have to take 1 mole. I have to take 1 mole, and they have given us 60 grams. So first of all, obviously we have to convert this grams into number of moles. Ye clear is up? Okay. The given information is in terms of number of moles. Now, please see. So what is the molar mass of aluminium? Number of moles of aluminium will be equal to number of moles of aluminium will be equal to the given mass divided by the molar mass. The given mass is 60 grams. Molar mass of aluminium, anyone? Molar mass of aluminium. 27, guys. You have to remember these things. Maybe in the you will get the molar masses and all in the examination. Maybe, है ना? कहीं टीचर अगर बोल गया तो फिर वो बोलेगा कि at least you have to remember the molar masses up till calcium. Till calcium, you should memorize the molar masses also. Okay, so this is the number of moles. Now, it's very easy to understand. Please see, guys. Please see. If I want to increase 1 Kelvin temperature of 1 mole, I will require 24 joules. Correct, guys? Yes or no? Please tell me. 1 Kelvin के लिए 1 Kelvin temperature of 1 mole, we require 24 joules. To increase 1 Kelvin temperature of 60 by 27 mole, we will require 24 multiplied by 60 upon 24. 24 multiplied 60 upon 27 joules. ये भी clear है? Unitary method बिल्कुल हाँ या ना?
Yes.
Clear है? Now I have to increase how much? I have to go from 35 degrees Celsius to 55. So what is the delta T here? Delta T is equal to 20. And if you remember correctly, 25 degrees Celsius or 25 Kelvin, both of these will be same. Yes or no? Please tell me. ये याद है सबको? If I am talking about the change in temperature, सर याद हो कम से कम? याद है?
Yes.
If I am talking about change in temperature, degrees Celsius and Kelvin, both of them are same. Now please see here, guys. So I have to increase the temperature by 20 Kelvin temperature of 60 by 27 mole. This will be equal to 24 multiplied by 60 divided by 27 multiplied by 20. 1 Kelvin के लिए you need this much. For 20 you have to multiply by 20. This much joules. Is this clear? Yes or no? Please tell me, guys. Now you will multiply this. You will tell me the answer. How much you are getting approximately. You see how much you are getting. 24 multiplied by 60 multiplied by 20 divided by 27. I forgot the answer. Please see how much you are getting. Can you answer in Zoom chat if you got the answer? Thank you very much, Siddhika.
Sir, could I see the question?
What question, Satika?
The question to this answer. I just joined, sir.
Okay, sorry.
Thank you.
I thought you asked me, should I send the question? I thought. You take a screenshot. Did anyone get the answer? Harsha, Mariam, Abdul Hamid. Harsha, correct. Very good. That is the number of joules, right? That will be the number of joules. So this will be equal to 1066.7 joules. I hope we are not making anything. Is there any blunder? I don't think so. There is any blunder, right? So how many kilojoule it will be? It will be equal to 1.066 or 06 kilojoules. I think that was the question. Calculate the number of kilojoules. So you have to put the values in kilojoules. Let me just quickly check the answer here. Number of kilojoules. I think it's times 6.9. Fine, it's correct. Please write this quickly. So, Siddhika, you forgot that you have to turn the camera on today also.
Sir, my
No, your
camera is on.
No, your camera is on. So you have modern problem requires modern solution. Yes, Siddhika.
Yes,
Yeah, last class you said that, sir. Last class you said that I could not turn the camera on because I don't have my hijab right now. Correct?
Sir, I have my camera on. My camera is on.
Said your camera is on. I know your camera is on. Don't worry. She has nicely put up a hoodie instead of a hijab, right? Siddhika?
Yes, sir.
That's what I was saying. Modern problem requires modern solution. Everyone done? All of you wrote this down? Yes or no? Please tell me. अब देखिए ध्यान से see Siddhika, you can take a screenshot for this now, and later please watch the recording. Okay, this is an important question. And see from here, what as you saw that this is as easy as calculating if 5 chocolate cost 50 rupees, what is the cost of 10 chocolates? Is that right? Yes or no? Please tell me. At least at your level, it is simply unitary method only, right? Now, what you can do, you can also have a formula for this. But I generally don't recommend this that you have formula for each and everything. You try to go into each question logically, that what they have given us here. This is the, you can say what, this is the cost, right? Joule per mole per Kelvin. So here we have 2 pers, that means per Kelvin also you have to increase that. If I am going from, we have been given for 1 Kelvin, but if I go for 2 Kelvin, then I will have to multiply 2. If I am going from 2 moles, I will have to multiply 2 for that also, right? So this joule per mole per Kelvin is kind of like a cost. And then as the moles and as the Kelvin is increasing, you have to just multiply those numbers. That's, but you can also write maybe formula for this, and mostly you will see this formula. The Q will be equal to the number of moles that is getting heated multiplied by the change in temperature multiplied by the molar heat capacity. So heat required will be equal to this. But again, this is nothing, just a fancy thing for an easy problem that is also done logically. Number of moles into delta T into Cn. That is it. Okay, if you want, you can write this down. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Now, please see, next thing that we are going to write is, see, we discussed many things here. We started with systems, surroundings, and pure definitions of the things. Then we started to move on and talk about energy. we talked about energy, and when we talked about energy, we talked about internal energy. Then we said that internal energy cannot be absolutely measured, so we are always talking about the delta U. And then we again proved that delta U can only be changed if we are giving it heat or we are taking out heat. That is, if there is an involvement of heat or there is an involvement of work. Then we went on to prove that W, it is nothing but minus P external delta V. यहाँ तक याद है सबको? Then we went on to various cases, and then we went into various use cases in which one of the most important thing was the measurement of heat at constant pressure, which was found to be delta H, which we named as enthalpy, the change in enthalpy. And since we are doing all the experiment in lab where the pressure is 1 atm, we always have a constant external pressure of 1 atm. We will be always talking about enthalpy. So whenever heat is released, agar aapko yaad ho class 10 se hi, when you are starting with chemical reactions and equations, you had these two terms, right? Endothermic and exothermic. Right? Endothermic and exothermic. Heat is required for that particular reaction. Sorry, I made a wrong. First, I will write endo and exo. Endothermic, that means heat is required in this type of reaction. Exothermic, heat is released in this type of reactions. So whenever we are talking about heat, in this cases of endothermic and exothermic, we are always talking about enthalpy, because all these chemical reactions will happen at 1 atm. Is this clear? Yes or no? Please tell me, guys. यहाँ तक clear है सबको? All good? ठीक है. So we have to also write about, if I am doing some reaction A plus B and it requires some heat, A plus B, let us suppose it is giving product, and I am saying this particular reaction is endothermic. It is endothermic. Then please tell me, it is endothermic. Then please tell me, if I have only A and only B with zero heat, I am not heating it. Please remember, this reaction is what? This reaction is, एक बार बोलने please. Endothermic. This reaction is endothermic. But I am not giving it any heat. So will this reaction happen? It will not happen. That means, can I say that for endothermic reactions, heat is one of the reactants. Or rather, at least I can say heat is like a reactant. Or if you don't agree with me, I can at least say that if you are not giving heat, the reaction is not happening. Then it is like a reactant only, correct? सही है? तो दिक्कत किसे को? नहीं ना? ठीक है. Similarly, if I have, that means I can write this reaction something. I should write this reaction something like this: A plus B plus some Q amount of heat it is given. Then only we are going to form a product. Is that clear? Please tell me, guys. Clear है सबको? ठीक. Similarly, for exothermic reactions, I will write A plus B, giving you product, and some heat will be released. सही है? For exothermic reaction, is this clear? Now, the chemical reaction that you studied in 10th standard, there you also balance the chemical reaction, right? You balance the chemical reaction only in terms of atoms, and only in terms of chemical species. Only in terms of chemical species. That is why you told and you said the chapter's name was Chemical Reactions and Equations. Now, as soon as we introduce this particular part of heat, we come on to a new topic, that is thermochemical equations. Thermochemical, please write the topic, thermochemical equations. What will be thermochemical equation having? We remember very well. I hope you always remember chemical equations. Now what we are adding just one more information, that is of thermodynamics, that is about heat, and that will become thermochemical equations. इसके बारे में एक दो लाइन लिखते हैं, फिर इसको अच्छी तरह से समझने की कोशिश करते हैं. Please write thermochemical equations, and then you write in this particular topic a balanced chemical equation. It will be a balanced chemical equation that gives the information about heat change about heat change during the reaction. During the reaction. Please write this down.
Done, sir.
So for example, I'm writing an example. For example, I have carbon, which will be in solid, plus O2, which will be in gas. Both of these will react and it will give you carbon dioxide gas, CO2 gas. This particular reaction is a combustion reaction. As you can see, it is a reaction with oxygen. We are reacting oxygen. Now, in this case, what we can write here, delta H will be equal to minus 393.5 kilojoule per mole. So obviously, when you have negative sign, that means heat is being released, and this reaction is also what? This reaction is an exothermic reaction. Now, please see here, guys. I am going to write this once again, and don't worry about the things here. Okay, so carbon solid plus O2 gas will give you carbon dioxide, which will be gas, as well as it is going to give you 393.5 kilojoule per mole of energy, 5 kilojoule per mole of 393.5 kilojoule per mole of energy. Now, please see what is the difference between the first equation and the second equation. Please see this very carefully. In the first equation, I'm writing delta H is equal to minus 393, and now I'm writing it as plus. Now, please remember when I talk about delta H, then delta H has a meaning. That means what is the heat involved? It is plus or minus. When delta H is involved, it is not talking about reactant or product. That is why I have to give a negative sign to say that heat is being released. But when I write this plus 393.5 kilojoule with CO2, I am already telling that it is a product. Is this clear? Yes or no? Please tell me, guys. दोनों में आपको दिख रहा होगा that sign is different, but both of these things means the same. दिख रहा है सबको? Right? So here we are putting negative sign because we have to explicitly tell delta H is talking about the release. With the negative sign, what does it mean? It is telling that it is in the product. We don't have to give energy, rather heat will be released by the reaction. And when we are writing plus 393 with CO2, here also we are telling the same thing. It is just a way of communication. Here we are already saying that that 393 kilojoule of energy will be in the product. And this negative sign also conveys the same thing. Is this crystal clear with everyone? Yes or no? Please tell me. Mariam, Shah, Martin, Abdul Hamid and Siddiqa.
Yes. Yes.
ठीक है, आप लोग कंफ्यूज नहीं होइएगा
Yes,
कि
sir.
नेगेटिव से पॉजिटिव कैसे हो गया. ठीक है ना? चलिए. Now, another thing is that whenever we have to talk about the thermochemical equation, we will also have to talk about standard version. For example, बात सुनिए, ध्यान सुनिएगा. If I burn 1 mole of carbon, there will be some heat release. सही है? If I burn, there will be some heat release. If I burn 2 moles of carbon, there will be more heat release. Correct? सही है ना? Now, as we are increasing the amount of carbon, what is happening? The amount of heat release is also changing. So we have to set a standard that whenever we are talking about the enthalpy change for a particular reaction, this is the standard. We have to measure things in 1 mole at this pressure, at this thing. So you will see a particular phrase repeatedly used, standard enthalpy of. So please write meaning of. What is the meaning of that phrase? Meaning of standard enthalpy of. You will see many things: standard enthalpy of combustion, standard enthalpy of formation, standard enthalpy of decomposition. Whenever you see this word standard enthalpy of, what does it mean? Please write here. First of all, it means that number one, please write, it is measured at 1 bar pressure. 1 bar and 1 atm, it is approximately equal. We generally take 1 bar. It is because it is easier to measure 1 bar, and it is easier to have a pressure of 1 bar in I mean, if you're having some controlled reaction, it is easier to have 1 bar of pressure because bar is directly related to Newton and meters per second. Force is directly related to that. What is pressure? It is force upon area, right? Force has a unit of Newton and area has a unit of what? Meter square. So 1 bar is 1 Pascal is Newton meter square, and 10 to the power 5 Newton meter square will be equal to 1 bar. Okay, so it is directly related with Newton meter square. That is why we use 1 bar, because it is physically and practically more achievable if you want to do any reaction in a controlled way. Next thing, it is very important. Second point is very important. Temperature can be anything. Temperature can be anything. That means it can have any value, but all the substance such substance should be in their standard form at that temperature. What does it mean? So for example, if I take the example of water, for example, if I'm talking about water and I'm talking some standard enthalpy of formation of water or standard enthalpy of decomposition of water, and if I'm talking at the temperature, let us suppose I'm talking at the temperature 298 Kelvin. So at 298 Kelvin, if water is involved in any reaction, it should be liquid. Is that clear? But if I am talking about water in a temperature, let us suppose 270 Kelvin. So 270 Kelvin is obviously less than 273, less than its less than its freezing point. So at 270 Kelvin, if I'm talking, it should be its solid state. And if I am talking about a water molecule involved in the reaction, and that reaction is happening at, let us suppose, 400 Kelvin, then the water molecule should be in the vapor phase. Is this clear? Yes or no? Please tell me, guys. ये चीज सही है सबको? कोई दिक्कत किसी को यहाँ पे?
Yes, sir.
ठीक है, clear है सबको ना? ठीक. Let me know if you have written this down, then I will move forward. Let me know if you are done. Done? ठीक. Now, we'll write enthalpy of formation. Okay, we are going to talk about different types of enthalpies. Write the number 1. Enthalpy of formation. Now, as soon as, see, this enthalpy of formation is important. As soon as I add standard enthalpy of, what will happen? It will be just 1 bar and temperature will be anything. ठीक है ना? Standard enthalpy से आपको घबराना नहीं है. Enthalpy of formation को याद रखिए. Standard में क्या होता है? Standard में it should be just 1 bar, and if they are also specifying what is the temperature, all the chemical species should be in their standard form at that particular temperature. Please write what is enthalpy of formation. Please write the delta H when 1 mole of a substance is formed from its elements in their most stable state. Write this down. Assalamu alaikum. Khadija, am I audible? Is Khadija, am I audible? ठीक है. See here guys, the delta H1, this is very important. So whenever they are specifying amount or anything, if we have to take a note, we have to form what? 1 mole of a substance is formed from its elements in their most stable state. Okay. So let us suppose we are going to talk about a very simple molecule, CO2, that we have already seen. We have to make CO2. Okay, and how many moles of CO2, guys? Tell me, how many moles of CO2? 1. Okay. We have to make 1 mole of CO2. So for this 1 mole of CO2, how many moles of carbon is required?
1.
See, ठीक. उससे पहले एक चीज हम लोग ये पहले क्लियर कर लेते हैं. That what are the elements forming carbon dioxide? Carbon dioxide is formed by, tell me guys. मार्टिन नहीं बोलना है तुमको कुछ. अरे माइक ऑन रखो भाई, अभी तो बिल्कुल वार्तालाप वाला स्टेज है. हाँ, कार्बन डाइऑक्साइड किस किस से बना हुआ है?
कार्बन डाइऑक्साइड लिखा.
हाँ सुनो, यही सुन रहे थे आप? क्या सुन रहे थे आप?
और मोल्स, राइट? how many moles?
You already know the question, right? Mariam, Harsha, Abdul Hamid, and Siddiqa. Huh, guys? You already know, na? What is the question? Kaha, where are you? Martin? Where are you?
Yes, sir, I'm here.
You are here, but why are you not listening? Your mic is also off. Why are you not listening? Martin, why are you not listening? If you are saying something, turn your mic on, Martin, if you want to say something. What happened? Your mic is not getting turned on.
It's
You can't turn
already,
your
sir.
mic. Keep it on, na? Keep it on. No need to turn that mic off. Keep it on. Now tell me, carbon dioxide, it is made up with what elements?
Carbon and oxygen.
Carbon and oxygen. So how will you get carbon? If I talk about the elemental state or the most stable state of carbon, any idea, guys? Anyone? Harsha, Abdul Hamid, Martin, or Siddiqa? Carbon, most stable state? You must have learned about allotropes of carbon in class 10. There are only
Solid.
2 ways of carbon solid, but carbon किस form में मिलेगा? Carbon solid, it will be there, but carbon has only 2 allotropes, no? You must remember this from your 10th standard. No. Abdul Hamid, correct. You will get carbon from graphite, not from diamond, obviously, right? You have only 2 sources of carbon, either graphite or diamond. याद आया सबको? हाँ guys.
Yes.
So carbon, and what? How will you get oxygen? What is the most stable state of oxygen?
Gases.
No idea. Sorry.
So gases state.
O2 gas plus O2. Okay, so when this reaction will happen, we will get 1 mole of carbon dioxide. We will get 1 mole of carbon dioxide. And as we have seen earlier, it is going to release an energy of minus 393.5 kilojoule per mole. So this reaction, whenever they say enthalpy of formation, they are talking about a reaction, and this is the reaction. So when they say enthalpy of formation of carbon dioxide is this much, so they say that when this reaction happens, and you have to accurately write the reaction, when this reaction happens, this much energy is released, or if it is in positive sign, this much energy is required. Now I'm going to write one more thing: enthalpy of formation of ammonia, NH3. So how many moles of ammonia should be formed? Tell me, guys. How many moles of ammonia? Boliye. How many moles of ammonia? 1. Very good. NH3. 1 mole of ammonia. Ammonia is NH3. So nitrogen, we will get nitrogen. What is the most stable state of nitrogen? What is the most stable state of nitrogen? No idea.
Yes.
बोलो भाई. N2 gas ना. N2 gas plus how many moles of hydrogen do we require? We will get hydrogen also, right? We require hydrogen also. But please remember, you will not balance this reaction as you used to balance it in the previous classes like this. You used to do it like this, right? 2NH3, and then you used to write here 3. You remember this? Yeah, there. But
Yes.
please see what is happening. If I write 2NH3, then I am forming how many moles of ammonia? Is that correct? If I form 2 moles of ammonia, is it correct? According to definition? Abdul Hamid, Harsha, you can say yes, sir. No, sir. ऐसे तो बोल सकते हैं आप कम से कम. If you don't want to turn the mic on. Is this correct, Harsha?
Yes.
2 moles of ammonia? According to definition, it is not correct, right? That is why whenever we are going to balance it, आप ऐसे balance कर लीजिए बिल्कुल. This is balanced, right? Then you have to make this product as 1 mole. So what you are going to do, you are going to divide. Here we have 1 mole, here we have 3, here we have 2. You will divide the whole equation by 2. So this will be by 2. This will be by 2, and this particular thing will be also by 2. So we will get here 1. So this particular reaction is we are talking about this particular reaction when we talk about enthalpy of formation of ammonia. Is this clear? Yes or no? Please tell me.
Yes.
Okay. So this will have some delta H, whatever the delta H, I don't remember. Okay, there will be some delta H. So delta H formation of ammonia. The reaction. Please write for a few more. Write the reaction involved. For delta H formation of number 1, write HCl. Number 2, you will write for H2O. Number 3, is there anything that I should write? HBr will be same thing. इतना कम से कम 2 कीजिए. HCl and H2. I think this will be enough for a practice. And once you're done, you will send the answers on my. Air नहीं होगा Abdul Hamid. It will be. I don't know why you wrote air. Once you're done, you will send the answers on my WhatsApp.
I don't have my phone with me.
You don't have your phone with you. Okay, fine.
Sorry.
Yes, Sadhika.
Turn my camera off for a minute. I'm using my phone. I'll send you the answer.
Yeah, no problem. can you show me like this? I think just hold it a bit up, a bit up, a bit up. Yeah. I think H2O1 is fine. HCl, yeah, I think HCl1 is also fine. A bit more up. Yeah, correct. Yeah, it's fine, it's fine. I see, it's fine. Martin and Abdul Hamid, please send your answers. Mariam, I'm waiting for your answer also. Mariam, did you send the answer?
I'm sending it, sir.
Achha. Is the H2O1 balanced, Mariam? Please see. Is the H2O1 balanced?
Yes, sir, I'm doing it.
Yes. Yeah, I've written it in a opposite manner, Martin. It will be hydrogen also one thing you have not written correctly. So please see here, guys. Siddhika, you have sent the answer. Yes, Siddhika, you sent the answer.
I did,
guys,
sir.
Where did you send? I did not get it till now.
1 second.
See here, guys. If we want to form HCl, you have to take hydrogen and chlorine. So hydrogen will be H2 plus you will have Cl2. This will give you HCl. Now, if you want to balance, you have to write 2 HCl here. Now, I don't want 2 HCl, rather I want 1 HCl. So I will have half of H2, half of Cl2, and I will have 2 by 2 of HCl. So 2 by 2 will give it 1 mole of HCl. Now, same thing goes for H2O also. If I want H2O, I have H2O. So I require hydrogen. So hydrogen will be from what? Hydrogen H2 gas plus oxygen will be from O2 gas. And now when I'm trying to balance this, I have to balance it in this particular way. I have to put 2 here because here we have 2 oxygen. And then I have to write 2 here also because we have 4 hydrogen here. So 4 hydrogen should be here. Now I don't want 2 H2O molecules because of the definition of enthalpy of formation. So I will divide this by 2. I will divide this by 1 by 2 and this will be 1 by 2. So I will actually get it as H2 because 2 and 2 cancels plus half of O2. That is going to give you 1 mole of H2O. Okay, these two will get cancelled. No, 2H2O is not required ना. वो तो 2 by 2 हो जाएगा, उसको काटना था आपको. नहीं सही नहीं है. देखिए गाइस, प्लीज देखिए, अगर आप रटने की कोशिश करेंगे, नहीं हम समझ रहे हैं आप लोगों ने क्या किया है. आप लोगों को यहाँ 1/2 लगा, वैसे नहीं करना है. You have to balance it then divide. ठीक है ना. आप लोगों ने कुछ हड़बड़ी की है कि हाफ हाफ कर देंगे तो सब हो जाएगा. हाफ हाफ करके करना है. हाफ हाफ नहीं है. You have to balance each reaction. Then you have, if you have any numbers in the product side, you have to divide that number. ठीक है. Please इसका ध्यान रखें. Please guys, this is the first number question and this is the second number question, the solution. ये हो जाना चाहिए था आप लोगों से. थोड़ा आप लोग प्लीज पेशेंस रखें ना, चीजों को सॉल्व करने की कोशिश किया करें, रटने की कोशिश ना करें.
Sir, I can't
Yeah,
hear you.
You can't hear me. Who can't hear me? Siddika? Siddika, you can't hear me.
Sir, your voice is a little glitchy.
For everyone, or is this for only Siddika? Harsha, can you hear me properly?
Yes.
I think it's only for Abdul Hamid and Siddika. Just a second. Let me still see my internet. No, my internet is fine. It's okay, no? Take it. So you have seen what is enthalpy of formation. Okay. Now, please write a question. Calculate the enthalpy of formation. Enthalpy of formation of HBr from the following data. They have given a reaction H2 plus Br2. It gives you 2HBr. This particular reaction has an enthalpy of reaction. It is given as minus 72.8 kilojoule per mole. Part of a reaction. ठीक है. ठीक है guys, please see. So this सवाल बहुत ही ज़्यादा आसान है. See here guys, what they are asking, what they are saying. Calculate the enthalpy of formation of HBr from the following data. And in the data, in the reaction, what is happening? You are reacting H2 and Br2, and you are getting how many moles of HBr? How many moles of HBr? 2 moles. Right. Very good. So 2 moles of HBr, and it releases this many moles of, sorry, this many kilojoules of energy. Correct? If I get 2 moles of HBr, it releases this many kilojoules of energy. Now, if I want to write the C, what they are asking you to write the reaction for the enthalpy of formation of HBr, which will be actually half H2 plus half Br2, and it will give you 1 HBr of 1 mole of HBr. Now, if 2 moles of HBr is giving this much energy, the enthalpy of this particular reaction will be minus 72.8 divided by 2 kilojoule per mole. अगर आपको 2 HBr से इतनी एनर्जी मिल रही है तो 1 HBr से उसकी आधी मिलेगी. करेक्ट गाइस? है ना? सिंपल. सो दिस इज वेरी इंपॉर्टेंट ना कि वो क्या पूछना चाह रहे हैं. सो व्हाट इज आल्सो इंपॉर्टेंट, इट इज इंपॉर्टेंट टू नो द डेफिनेशन ऑफ एंथैल्पी ऑफ फॉर्मेशन. अदरवाइज आपको लगेगा एंथैल्पी ऑफ फॉर्मेशन क्या होगा. आप समझिए सवाल को कि अगर आपको एंथैल्पी ऑफ फॉर्मेशन में 1 मोल का इंपॉर्टेंस नहीं पता है, इफ यू डोंट नो व्हाट इज द इंपॉर्टेंस ऑफ फॉर्मेशन ऑफ 1 मोल ऑफ द सब्सटेंस, देन यू विल नॉट बी एबल टू इवन get the question why the question is even there. They have already written that the enthalpy of formation. आप ये समझिए ना सवाल को कितना ज्यादा confusing हो सकता है if you don't understand what is enthalpy of formation, because what we are forming here, if you just see it, आप एक क्लास पहले इस रिएक्शन को देखते, what we are forming, क्या फॉर्म कर रहे हैं हम? HBr. What we are forming in the reaction, HBr ना, and they are asking enthalpy of formation of HBr. तो आप आंसर क्या लिख के आते? minus 72.8 किलोजूल. ये लिख के आते ना. So it is very important to attend each and every class and to understand what is this enthalpy of formation. Then you will see enthalpy of combustion. तो कहाँ पे, what is the crux point of that particular definition is also very important. कि आपको form क्या करना है. Reactant में कुछ भी हो रहा हो, that doesn't matter. I have to form 1 mole of the product, 1 mole of the substance. It doesn't matter whether we are taking half or whether we are taking 3/2 moles of reactant. At the end, in my product, I should have 1 mole of the 1 mole of the product, whenever we are talking about the enthalpy of formation. Is that clear? Yes or no? Please tell me, guys. ठीक है, चलिए प्लीज नोट दिस डाउन क्विकली. इसी वजह से थर्मोडायनेमिक्स इज वेरी कंफ्यूजिंग समटाइम्स, है ना. यहाँ पे उन्होंने कुछ दिया ही हुआ नहीं है. ठीक है, चलिए दे हैव ओनली गिवन, आप ये समझ सकते हैं उन्होंने क्या दिया है, सिर्फ और सिर्फ एक वैल्यू, एक नंबर से आपको बोला है कुछ कैलकुलेट करने के लिए. क्या कीजिएगा आप, देयर आर 4 ऑपरेशन जो आपको पता है ना. मल्टीप्लीकेशन पता है आपको, एडिशन पता है, डिविजन पता है, और क्या पता है आपको, सब्ट्रैक्शन पता है. यही 4 ऑपरेशन का यूज कर करके 10th क्लास से आप लोग 11th क्लास आए, है ना. कुछ नहीं दिया रहे, आपको कुछ पता भी नहीं हो, आप क्या करते थे, या तो मल्टीप्लाई करते, या तो ऐड, या तो डिवाइड, या तो सब्ट्रैक्ट, कुछ नहीं आता था. लेकिन उसके लिए तो यू रिक्वायर 2 नंबर्स ना. क्या चाहिए आपको, यू रिक्वायर एटलीस्ट 2 नंबर्स. यहाँ पे यू हैव ओनली 1 नंबर, और वो दूसरा नंबर 2 कहाँ से मिला आपको, यहाँ से मिला. ठीक है, सो इट्स वेरी इंपॉर्टेंट. केमिस्ट्री इस वजह से डिफिकल्ट हो जाता है जब भी न्यूमेरिकल्स आ जाएंगे, बिकॉज यू हैव टू एक्सट्रैक्ट द इंफॉर्मेशन फ्रॉम द वर्ड्स. इसके बाद हम लोग एक थोड़ा सा बहुत हल्का सा पॉइंट है, उसको लिख लेते हैं. स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन.
The unit of enthalpy is kilojoule per mole.
The unit of enthalpy.
Yes.
It depends on, I mean, different aspect, but it will always have joules in it.
Okay.
ठीक है, it will always have joules in it. क्या, क्योंकि वो basically heat है, but whenever we have to standardize something ना, उसको per gram, per mole, पर कुछ कर देते हैं, right? So that is why we have per mole here. Got it, Harsha?
Yes.
Please write standard enthalpy of formation. This will be represented by delta H. The subscript you will have F, and here you will have degree type of sign. Delta HF naught. F is in the subscript, that means it is in the legs of H here. It is in the subscript. Standard enthalpy of formation. तो बेसिक सी बातें आप लोगों को पता होगी. इट इज द एंथैल्पी ऑफ फॉर्मेशन मेजर्ड एट 1 bar प्रेशर. दिस इज डेल्टा HF. ये कुछ नहीं है, इट इज डेल्टा HF ओनली, व्हिच इज measured at 1 bar pressure. Right, next, delta HF is AKA, also known as, इसको आप और कैसे देखिए, स्टैंडर्ड मोलर enthalpy of formation. Enthalpy of formation. ठीक है, it is the same thing. If they are written na standard molar enthalpy of formation, it is the same thing as delta HF naught. Delta HF naught कर दीजिएगा इसको. Delta HF naught is AKA standard molar enthalpy of formation. Right, the next point. Delta HF naught, that means standard enthalpy of formation of elements in their standard state, elements, or rather in their most stable elements in their most stable state, is taken as 0. क्या मतलब हुआ? For example, if I want to talk about the delta HF naught of O2 gas, अब एक बात समझिए ना, what we are asking the enthalpy of formation of O2 gas. That means I have to write in my product O2. सही है? और O2 का elemental form क्या होता है? O2. So O2 से O2 जाने में what change? O2 ना, तो delta H क्या हो जाएगा? 0. Is that clear? Yes or no? Please tell me, guys. बात साफ है ना? चलिए. So standard enthalpy of formation इस तरह से, जैसे O2 का कुछ नहीं होगा, है ना? Similarly, for example, if I have N2 gas, it is available in the universe as N2. Then you will have carbon in the form of graphite. Carbon in the form of graphite, it is also taken as 0. Done everyone? Yes or no? Please tell me.
Yes, sir.
सिद्दीका है, सिद्दीका नहीं है, सिद्दीका हाँ हाँ हाँ
Done,
ठीक है
sir.
ठीक है, आप हैं आप हैं, ठीक है। सिद्दीका समझ में आ रहा है सब? आता है ना, ठीक है चलिए। So we have seen, generally speaking, for any reaction, I hope you have written, for any reaction I will talk about the enthalpy of that particular reaction. ठीक है, standard enthalpy of that particular reaction, and we have also studied enthalpy of formation or standard enthalpy of formation. Now we are going to talk about the relationship between the enthalpy of reaction and enthalpy of formation. Enthalpy of reaction and enthalpy of formation. अब समझिए थोड़ा बात को, बहुत इंपॉर्टेंट है ये चीज समझना, रटने की आपको जरूरत नहीं है। वी आर गोइंग टू डिराइव, क्या बुक डिराइव करेगा एनसीईआरटी या फिर जो थर्मोडायनेमिक्स करते हैं वो नहीं। वी आर ओनली गोइंग टू डिराइव द रिलेशनशिप बिटवीन the enthalpy of reaction and enthalpy of formation. Let us suppose we have a reaction that we are going from A to B. We are going from A to B. Clear है सबको? ठीक है, अब सुनिए। As we are going from A to B, we are destroying A. बात सही है? We are destroying A and we are forming B. B का हो रहा है फॉर्मेशन और A का क्या हो रहा है? A का क्या हो रहा है? अरे बोलो भाई, डिस्ट्रक्शन हो रहा है। A का क्या हो रहा है?
Destroy.
डिस्ट्रक्शन हो रहा है। Now I can say that destruction is opposite of what? Opposite of, अरे बोलो, opposite of, खुद से बोलो।
Formation.
क्या जरूरत है आप लोगों को किताब की, बताइए। अपोजिट ऑफ फॉर्मेशन, और ये तो फॉर्मेशन हो ही रहा है, तो ये क्या है? ये तो फॉर्मेशन है ही, ये तो फॉर्मेशन है ही है। अच्छा, यानी कि ए के लिए, ए के डिस्ट्रक्शन में हमारे पास कुछ एनर्जी का इन्वॉल्वमेंट होगा। टू डिस्ट्रॉय ए देयर विल बी सम इन्वॉल्वमेंट ऑफ एनर्जी व्हिच विल बी अपोजिट ऑफ फॉर्मेशन। So I can write that this whatever energy is required to destroy A, it will be equal to minus delta H F naught of A, है ना? अपोजिट ऑफ फॉर्मेशन का मतलब क्या? नेगेटिव साइन लगा देना बस, समझ में आ रही है? अगर मत समझिए, अगर ए के फॉर्म होने में एनर्जी रिलीज हो रही है, when A was getting formed, then energy was released, तो डिस्ट्रॉय करने में एनर्जी लगेगी, समझ में आ रही है? और अगर A के फॉर्म होने में एनर्जी कंज्यूम हो रही थी, तो A के डिस्ट्रॉय होने में एनर्जी रिलीज होगी, उल्टा ऑफ डिस्ट्रक्शन ना। तो वी हैव जस्ट पुट अ नेगेटिव साइन टू शो दैट इट इज अपोजिट। और यहाँ पे B के लिए क्या लिख देंगे? सिर्फ डेल्टा एच एफ नॉट ऑफ B, बिकॉज फॉर्मेशन ही तो हो रहा है B का। ये बात सही है? इज दिस क्लियर? और both of these things will together tell about the enthalpy of reaction. यही दोनों चीज तो हो रही है रिएक्शन में। रिएक्शन हो क्या रहा है? डिस्ट्रक्शन ऑफ A एंड फॉर्मेशन ऑफ B। बात क्लियर है? अरे बात क्लियर है कि नहीं? ठीक है ना? हमारे पास क्या है? रिलेशनशिप आ गया। What will be the relationship? Delta H naught of a reaction will be equal to delta H F naught of the product minus delta HF naught of the reactant. जो रिएक्ट कर रहा है उनका उल्टा है, मतलब डिस्ट्रॉय हो रहा है जिसका, तो उसका नेगेटिव ऑफ फॉर्मेशन, एंड व्हाटएवर इज गेटिंग फॉर्म्ड उसका पॉजिटिव ऑफ फॉर्मेशन। आसान, सिंपल, यस और नो, प्लीज टेल मी। ठीक है?
Yes.
अब इसी में समझिए, अगर आपके पास एक प्रोडक्ट है तो आपने एक प्रोडक्ट लिखा, लेकिन इफ यू हैव मल्टीपल प्रोडक्ट तो हम लोग क्या लिखेंगे? अब ये सिग्मा इग्मा आके आप लोग घबराइएगा मत, वो बात एक ही है, बिल्कुल, है ना? आप यही याद रख के चलिए, लेकिन नोटबुक में ये सारी चीजें रहनी चाहिए। सिग्मा मतलब समेशन ऑफ डेल्टा एच नॉट एफ ऑफ प्रोडक्ट, यानी कि जितने भी प्रोडक्ट है उनका एंथैल्पी ऑफ फॉर्मेशन, माइनस समेशन ऑफ डेल्टा एच नॉट एफ जितने भी रिएक्टेंट है उनका एंथैल्पी ऑफ फॉर्मेशन का समेशन। बात समझ में आ गई? ठीक है ना? आई होप ये सिग्मा से आप लोग घबराए नहीं होंगे। ठीक है, प्लीज राइट दिस डाउन। Let me know once you're done, guys.
Done, sir.
Write the question. Please write the combustion of the combustion of 1 mole of benzene gives CO2 and H2O with 3267 kilojoule of heat at 298 Kelvin. At 298 Kelvin. And 1 bar of pressure भी कर दीजिए, and 1 bar of pressure. And 1 bar of pressure. Calculate the enthalpy of formation delta HF naught of benzene if delta HF naught of CO2 is equal to minus 393.5 kilojoule per mole and delta HF naught of H2O, it is equal to minus 286 kilojoule per mole. अब देखिए यहाँ पे सबसे पहली बात, लाइक व्हाट आर द लेवल्स जहां जहां पे आप अटक सकते हैं ना, ये एक सवाल है, ठीक है ना, इमीडिएटली इम्पॉसिबल सवाल, बहुत सारे लोगों को बहुत कुछ आता भी होगा तब भी बहुत लोगों के लिए इम्पॉसिबल हो सकता है। सबसे पहले फर्स्ट ऑफ ऑल सवाल पूछ क्या रहा है, सवाल पूछ क्या रहा है, इट इज टॉकिंग अबाउट द एंथैल्पी ऑफ फॉर्मेशन ऑफ बेंजीन एंड दे हैव गिवन सम पर्टिकुलर रिएक्शन, सो यू हैव टू फर्स्ट ऑफ ऑल राइट दिस इंफॉर्मेशन as a thermochemical equation. Reaction हो रहा है ना ये, the combustion of 1 mole of benzene gives CO2 and H2O with 3267 kilojoule of heat. So they have also given you, they have given you chemical reaction with some information about the heat. तो आपको क्या लिखना है, thermochemical equation यहाँ से लिखना पड़ेगा. How can you write the thermochemical equation? उसके लिए आपको चाहिए benzene का formula. Does anyone know what is the formula for benzene?
C6H6.
हाँ, दो सुनो, वेरी गुड। तो ये सबसे पहला लेवल है, कुछ लोगों को नहीं पता। मरियम, आपको पता था बेंजीन का फॉर्मूला?
I wasn't sure.
हाँ, नहीं, अरे कोई दिक्कत नहीं, अभी तो पढ़ नहीं गया ना, अभी एग्जाम में ना हो क्या। ये बता रहे हैं आपको लेवल्स है ना। सबसे पहले तो करना क्या है, सबसे पहले यू हैव टू आइडेंटिफाई, ओके फाइन, आई हैव टू, दे हैव गिवन मी अ पर्टिकुलर थर्मोकेमिकल इक्वेशन, आई हैव टू राइट इट, दे हैव गिवन मी इन वर्ड्स, आई हैव टू राइट इट इन टर्म्स ऑफ इक्वेशन विद एरो एंड, ठीक है। उसके बाद आपको पता होना चाहिए बेंजीन होता क्या है, ठीक है। सो दिस इज द सेकंड लेवल, C6H6। कंबशन मतलब रिएक्शन विद, ये सबको पता था? मतलब ऐसे हर्षा ने बताया तब आपके ध्यान में आया या फिर आपको पता था कि O2 के साथ अब रिएक्शन होने वाला है? ये बताइए आप। पता था? सिद्दीका, मरियम, अब्दुल हमीद? हाँ, नहीं पता था। मरियम नहीं, दिख नहीं रहा था ना, दिख रहा था कि O2 के साथ रिएक्शन होगा? सिद्दीका दिख रहा था? चलिए, दिख रहा था जिनको, उनके लिए बहुत बड़ी खुशखबरी, यू हैव पास द लेवल 3, ठीक है ना। O2 के साथ रिएक्शन। अब इसमें प्रोडक्ट क्या मिलेगा आपको, दे हैव ऑलरेडी स्टेटेड, सो से थैंक यू टू द क्वेश्चन, उन्होंने पहले बता दिया कि मिलेगा क्या आपको, है ना। उसके लिए आपको याद रखने की जरूरत नहीं है, यू हैव टू जस्ट राइट हियर CO2 and H2। Then the next hurdle is to balance this। अच्छा, H2 और साथ साथ हम ये लिखते हैं। अच्छा, डेल्टा H कितना होगा बताइए जरा। डेल्टा H of this reaction will be equal to how much? कौन बताएगा डेल्टा H for this reaction? हर्षा बताइए। What will be the enthalpy of this reaction? They have given ना, सिद्धिका बताएंगे।
3267
3267 किलो जूल्स। अब ये बताइए प्लस में माइनस में क्या ख्याल?
प्लस
सिद्धिका, हाँ ये दिख
माइनस
रहा है प्लस। क्यों प्लस या माइनस फिर आएगा ना, मेरे समझ में आएगा ना क्यों। They have given it in positive, so why you are writing in negative? आप नेगेटिव बोल ही क्यों रहे हैं? क्या ख्याल है मरियम, मार्टिन, अब्दुल हमीद, क्या होगा पॉजिटिव या नेगेटिव?
Positive.
नेगेटिव होगा। क्यों होगा नेगेटिव मरियम? क्यों मन कर रहा है मेरा नेगेटिव? हाँ क्यों होगा नेगेटिव? सवाल में कुछ तो बताया होगा ना, पॉजिटिव होगा नेगेटिव होगा उसके बारे में। पढ़िए सवाल को, क्या बोला उसने। चलिए हम लोग थोड़ा हिंदी अनुवाद करते हैं। हिंदी अनुवाद समझते हैं, ट्रांसलेशन। जब 1 मोल बेंजीन का कंबशन होता है तो क्या क्या मिलता है आपको, बताइए क्या क्या मिल रहा है, बोलो।
CO2, H2,
CO2, और क्या मिल रहा है,
H2,
और क्या मिल रहा है,
Enthalpy,
और क्या मिल रहा है,
heat,
जोर से जोर से।
heat,
हीट, तो हीट मिल रही है ना, सिस्टम इज गिविंग हीट। यहाँ पे तो लिखा हुआ है बिल्कुल सवाल में, क्या लिखा हुआ है, ऐसे खोल खोल के लिखा हुआ है ना उन्होंने। क्या लिखा है, इट इज गिविंग। गिव का मतलब क्या हो जाएगा, नेगेटिव। ये बात समझ में आएगी नहीं है सबको, हाँ या ना बताएं।
yes,
किसी को कोई दिक्कत? माय गॉड, प्लीज इट हियर, या फाइन। नाउ बैलेंस कीजिए जरा रिएक्शन को। अब आई एम जस्ट टेलिंग यू अबाउट द लेवल्स। अभी तो सवाल स्टार्ट नहीं हुआ ना, अभी तो हम लोग इन्फॉर्मेशन लिख रहे हैं। So we are till here, कैलकुलेशन तक पहुंचे नहीं है। We are writing whatever information is giving. So there are levels of hurdles. पहले क्या करना है, कंबशन रिएक्शन कैसे होगा नहीं होगा, then C6H6 होता है, then enthalpy of that reaction will be positive या negative। अब आइए बैलेंसिंग पे, बैलेंस कीजिए जरा। चलिए आपको हम 1 मिनट देते हैं और ना, बैलेंस कीजिए क्योंकि क्लास का टाइम फिर खत्म हो जाएगा ना। अब्दुल हमीद यहाँ तक आ रहा है आपको समझ में? इस अब्दुल हमीद, ठीक है। खदीजा तो कहाँ है पता नहीं। खदीजा इज देयर इन द क्लास, आई कैन सी, बट नॉट इवन रिप्लाइंग एनीथिंग। चलिए 1 मिनट इज ओवर। एनीवन, किसी ने कुछ किया अभी तक? मरियम, मरियम, हर्षा, मार्टिन एंड सिद्दीका, प्लीज स्टॉप, प्लीज स्टॉप, रुक जाइए, थम जाइए, थम जाइए बस। हाँ बताइए क्या आया, कुछ आया? हाउ मेनी, हाँ माइक ऑन करके बताइए कितना C6H6 में। चलिए अब बताइए ना, ए कितना, बी कितना, सी कितना और डी कितना। ए इज इक्वल टू, मरियम, सिद्दीका बोलेंगी।
A0.
ए जीरो, ए जीरो। मरियम आपका क्या है, ए कितना?
2,
एक 2। हर्षा आपका ए कितना?
So 1.
1। मार्टिन, व्हाट अबाउट योर ए?
0.
0। देखिए सबसे पहली बात तो जो लोग 0 लिख रहे हैं, भाई 0 कभी नहीं होता है। इफ बेंजीन इज 0 तो बेंजीन रहा ही कहाँ, 0 बेंजीन लेंगे क्या आप? बताओ सिद्दीका, मार्टिन, 0 बेंजीन तो नहीं लेंगे ना? मेरी बात समझ में आ रही है?
No, sir.
हाँ, अगर कुछ नहीं है, इफ देयर इज नथिंग तो मतलब 1 है। बात समझ में आई? ठीक है ना, अगर
Yes.
आपके इक्वेशन ठीक। और दूसरी चीज मरियम, जो आपने 2 लिखा है यहाँ पे, 2 कभी भी नहीं लेंगे, बिकॉज वी आर टेकिंग हाउ मेनी मोल्स ऑफ बेंजीन।
1.
ठीक है, ये ध्यान रखिएगा आप खासतौर से कि ये 1 ही रखना है यहाँ पे हमको। ठीक है, अब उसके बाद इफ यू हैव टू कीप बेंजीन एज ओनली 1, तो आप देखिए कितना आसान हो जाएगा इसको बैलेंस कर। प्लीज सी हियर गाइस, फर्स्ट ऑफ ऑल आई विल राइट हियर C6, तो ये कार्बन तो 6 ही रहेगा, इसके ऊपर ये जा ही नहीं सकता, ना ही कम हो सकता है। ये बात समझ में आई सबको? इफ C6 इज ऑलरेडी देयर ना, ये तो यहाँ पे हमेशा कितना रहेगा, 1। वी कैन नॉट चेंज दिस 1, इस 1 को हम लोग चेंज ही नहीं कर सकते। तो कार्बन विल नाइदर बी 5 नॉर बी 7, इट विल बी 6 ओनली। अब बची बात ऑक्सीजन को बैलेंस करने की, सो प्लीज सी। अच्छा, एक और चीज हम लोग यहाँ पे कर सकते हैं इसको। हाइड्रोजन इज 6, राइट? हाइड्रोजन इज 6, सो दिस वाटर मॉलिक्यूल विल बी 3। H2O कितना होगा, 3 ना, 3 2 6। नाउ दिस कैन नॉट आल्सो नॉट चेंज, दिस विल आल्सो नॉट चेंज। बात सही है? अब रही बात बस ऑक्सीजन को बैलेंस करने की, सो लेट अस काउंट द नंबर ऑफ ऑक्सीजन एटम्स हियर। 6 2 12, 12 plus 3 is equal to 15. I will write here 15 O2, यानी 15 मतलब 15 by 2 O2। अब देखिए, is everything balanced? देखिए guys, all of you please see, is everything is balanced? सब कुछ बैलेंस है?
Yes.
ठीक है, अब समझिए। Now you have written the thermochemical equation. अब इसके बाद हमारे पास आ जाएगा क्या, डेल्टा H नॉट R। I mean this is the H नॉट R ही है। Why? Because this why is this H नॉट? Because we are doing this in standard form ना, 1 bar of pressure है ना, तो 1 bar pressure है, तो ये डेल्टा H नॉट R। या आप अगर HR भी लिखे तभी कोई दिक्कत की बात नहीं है। H नॉट R will be equal to the summation of delta HF naught of products minus the summation of delta HF naught of reactant। ठीक है, अब ध्यान से सुनिए जरा, आप लोग प्लीज कुछ लिखिएगा मत, ध्यान से सुनिए। पेन बिल्कुल ऐसे करके नीचे रख दीजिए। कीप योर पेन असाइड एंड लिसन वेरी प्रॉपरली एंड कीप योर माइक ऑन ऑल्सो। माइक भी ऑन करके रखें, माइक ऑन करके रखें प्लीज। मरियम, हर्षा, मार्टिन, all of you guys. So what are the products? Tell me guys, what are the products? In the product we have CO2, ठीक है ना? How many CO2?
6.
6. So 6 into delta HF naught of CO2, सही है ना? क्योंकि when we are talking about enthalpy of formation, we are talking about 1 mole of formation, बट यहाँ पे 6 मोल्स ऑफ CO2 फॉर्म हो रहे हैं, तो क्या करेंगे हम वहां पे 6 into, ठीक है, प्लस what it else is getting formed, water, so it will be, बोलिए वाटर के लिए क्या लिखें?
3.
3 into delta HF naught of H2O, ठीक है, फाइन, माइनस, अब यहाँ पे लग जाएगा एक बड़ा सा ब्रैकेट। नाउ टेल मी, माइनस व्हाट आर इन द रिएक्टेंट एंथैल्पी ऑफ फॉर्मेशन ऑफ,
Benzene.
बोलिए, बेंजीन। बेंजीन कितना मोल है? 1 मोल। I will write enthalpy of formation of benzene of C6H6, then plus the enthalpy of formation of plus the enthalpy of formation of O2, but 15 by 2 also ना, into delta H naught F of O2। यहाँ तक सबको क्लियर है, हाँ या ना, ये बताएं।
Yes, sir.
ठीक है, अब चलिए एक एक करके हम लोग वैल्यू डालें। आप लोगों को CO2 वगैरह का वैल्यू दिया हुआ है, चलिए बताइए। डेल्टा एच नॉट आर आपके पास जो भी है उसको हम लोग बाद में लिख लेंगे। चल अभी लिख लें क्या, डेल्टा एच नॉट आर कितना, -3.3267 -3267 -3267 दिस इज इन किलो जूल, इसको याद रखेंगे, इज इक्वल टू 6 into एंथैल्पी ऑफ फॉर्मेशन ऑफ CO2 कितना है, एंथैल्पी ऑफ फॉर्मेशन ऑफ CO2, अरे लिखो मत भाई, बोलो, अरे फिर लिखने लगे आप लोग, बोलो भाई, बोलो अभी बोलो। एंथैल्पी ऑफ फॉर्मेशन ऑफ CO2 कितना है, -393.5। ठीक है, उसके बाद प्लस 3 into हाउ मच फॉर फॉर्मेशन ऑफ H2O,
286.
-286 किलोजूल पर, ठीक है, माइनस एंथैल्पी ऑफ बेंजीन, ये हम लोग को नहीं पता, सही है। Now minus and this plus, it will again have minus the -15/2 डेल्टा H नॉट F O2 के लिए, क्या we don't know two values अब, है ना, ये वैल्यू भी नहीं पता, ये वैल्यू भी नहीं पता, है ना।
Yes.
And we have only, how many equation do we have here, only one। क्या करें हम, फिर फंस गए, बताइए, फंस गए क्या ख्याल है, मरियम, हर्षा एंड सिद्दीका, मार्टिन एंड अब्दुल हमीद, क्या ख्याल है, फंस गए, वी आर वंस अगेन स्टक, बताइए। अब हम आपको एक चीज बता रहे हैं, एंथैल्पी ऑफ फॉर्मेशन ऑफ O2 कितना होगा, किसी को याद हो तो बताएं।
So 0.
हाँ, कितना होगा, कुछ याद आया किसी को कि नहीं याद आया, मरियम याद आया, 0, क्यों 0, बिकॉज इट इज इन इट्स एलिमेंटल फॉर्म, एलिमेंटल फॉर्म में है ना O2, तो ये क्या हो जाएगा, ये तो खत्म, इसको लेने की जरूरत है ही नहीं। अब देखिए कितना आसान हो गया हमारे लिए, वी हैव, बस ये देखिए, माइनस डेल्टा HF नॉट HC6H6 है ना, इस पूरे टर्म को हम लोग LHS में ले आते हैं एंड इस टर्म को हम लोग इधर ले आते हैं, ठीक है। सो वी विल गेट डेल्टा HF नॉट ऑफ C6H6 will be equal to whatever this value is, 6 into -393.5 plus 3 into -286, then we will have -3267, इसको कर देंगे क्या, plus 3267, and whatever the answer will be, we will be getting this in kilojoule, ठीक है। थोड़ा कैलकुलेट करते हैं आपके लिए, अब यहाँ पे बस कैलकुलेशन है, कैलकुलेशन से मत घबराइए, कैलकुलेशन से घबराइएगा तो बड़ी दिक्कत हो जाएगी। 393, नेगेटिव साइन का खास ध्यान रखें आप लोग, प्लस 3 into -286 plus 3267 will be equal to, सही, ठीक है। when you calculate this whole thing, जरा कैलकुलेट कीजिए थोड़ा सा कैलकुलेट, है ना, 2-3 मिनट तो लगाइए कैलकुलेट करने में। Anyone got the answer?
So I'm getting 48.
Yeah, very good. That is correct. 48 kilojoule. This is the enthalpy of formation of benzene. Okay. And because since in benzene we are using 1 mole, so आप इसको 48 kilojoule per mole भी लिख सकते हैं. 48 kilojoule per mole. Is this clear, guys? Yes or no? Please tell me.
Yes.
Okay. So that is it for today. आज के लिए इतना ही. And in the next class we are going to look at some more thermochemical equation. There are only 2 more classes left. ठीक है ना? हम लोग next class में थोड़े और जैसे enthalpy of combustion देखेंगे, enthalpy of vaporization देखेंगे, and we'll talk about some other enthalpies, and that will be on next Saturday. And we will be involving many problems like this. Then we are going to talk about another thing that is known as the Gibbs free energy delta G. And then we are also going to talk about entropy. Okay. So this particular class, that is the next class, that will be very important if you think in terms of the questions. And if you think in terms of the exam, if you are going to have for thermodynamics, then this class, the next Saturday class will be very important. And the last class of thermodynamics that will be on the next Sunday, it is very important in general also. You will learn about the most important thing in science, that is entropy, why anything happens. We will try to answer the question of why anything happens.